Welcome to Lecture 8. Lecture 8 is based on Chapter 8 of your textbook, and it deals with the idea of sampling. So, when we conduct research, in an ideal situation, we would like to be able to test the entire population to find out a certain area that we are interested in. Say, for example, we are interested in knowing people's opinions to a new bill that's been passed in Parliament. It would be ideal to poll every person involved and ask them about their opinion. That might not be possible because population sizes tend to be enormous. And really, there might not be any added significant information if you polled, say, the 170,000 residents of Sudbury, or if you polled a well-screened or an appropriate sample of, say, 100 people who perhaps represent or are a representative sample for the population of the entire city. In a similar manner, if you wanted to understand how people feel in their employment efforts following a prison sentence or something like that, you would specifically seek out people who are willing to talk about their experiences and who have had a criminal record in the past. And that involves a different kind of sampling. Again, you can't sample everybody because that's not relevant, and you can't also sample all the people who may have been incarcerated in the past because they may not be willing to talk to you about their challenges. So this is why we work with samples, which are a subset of the larger population that we are trying to study. What a sample should reflect really depends on what question we are asking. Samples can be random. Samples do not always have to be random, and it depends on what you're trying to study. If you want to ask the question, how do older Italians in Sudbury feel about their grandchildren not learning Italian, it's somewhat pointless to draw a random sample from the city of Greater Sudbury because not everybody is Italian, and not all older adults with children care that their children learn Italian if they aren't Italian in the first place. Okay. Sampling is required more in quantitative studies and qualitative studies because the perspective presented and the research done is to present the individual lens of perspective. Sampling is not such a big deal for qualitative work. There are two primary kinds of sampling: random sampling and non-random sampling. As you can probably tell, the name suggests what these two types of sampling involve. Chapter 9, I believe Chapter 9, Chapter 8, gets into first non-random sampling. And when we look at non-random sampling, there are several types of non-random sampling. Oftentimes we are limited to using non-random sampling because either it represents the population that we wish to study more accurately, or we simply have no choice because of the limits of time and resources. The first non-random sampling you're introduced to is called accidental sampling. It's also called a convenient sample. The reason it's not random is, let me give an example of an accidental or a convenient sample. So if my classroom of Gerontology 3127 research methods, let's say all of you students, consented to work on a study for me as part of, say, course improvement process. We did it through a means by which I would not know who participated and who didn't. We had a third person come and administer the experiment. In that situation, I used a sample that was available to me, my students. Of course, there are lots of ethical considerations when professors decide to use their own students to study because there is a massive power differential between the professor and the students. And so that has to be considered by an ethics board before approving any such kind of a study. But as a hypothetical example, it's a convenient sample, okay? It's not random. Even though as a professor I would have had no role in picking who is in the class, it is still convenient. If my research question is relevant to understanding how upper year Tim Hortons students purchase Tim Hortons how upper year university students purchase Tim Hortons coffee. Sorry about that. So if I was interested in knowing how each of you purchased your coffee, whether you used cash, credit, or debit, if that was my area of interest in study, and it was very specific to knowing how third or fourth year students did, then using a classroom population such as yourselves would be the right sample to ask that question. Now, it wouldn't be an appropriate sample if I wanted to test competency in gerontology, because you're all third-year students in gerontology, and having taken a lot of gero courses, doing that kind of an analysis on you is somewhat meaningless because the tests will be all skewed towards indicating that all of you have sufficient gerontology competence. So one has to think about what kind of sample they will use and for precisely what reason. A second type of non-random sampling is called accidental quota sampling. So let's assume that I wanted to compare use of university bursaries between two sets of students. So if I'm thinking university bursary, and if I want to compare the use of university bursaries between Francophone students, males and females, then I specifically have to request a professor teaching a French course to be able to use their classroom. And if I find that there are more females than males significantly, or the other way, because I want same number of each type, I would pick 50 Francophone males and 50 Francophone females to study their application and use of bursaries offered by Laurentian University. Okay, so we are predefining certain characteristics, saying that, well, what bursaries are available to students that are Francophone, and then we're asking the question as to whether males tend to use it more or females. And because we want to compare apples to apples, we decidedly take only a certain number of students, especially if one gender in this case is overrepresented. Okay, so this is a quota because we choose the same number, but it's still accidental because there is no randomness in the process. Purpose of sampling is a little bit different from accidental and accidental quota sampling in the sense that if we wanted to compare academic performance, let's say in terms of the very controversial EQAO testing between 3 rural schools for grade 3. Okay, so if this is what we wanted to look at, we wanted to compare academic performance between 3 rural schools for grade 3, and we want to look at EQAO testing, the sampling would not be random in the sense we're not picking up 3 random schools. We are purposefully or purposively picking up 3 rural schools that we will compare between. Okay, so this kind of sample is called a purposive sampling. These are best suited in case study situations. And what happens is if we're trying to understand the role of a certain introductory factor to one of these three schools or all three schools and then evaluate a before and after or just compare one school to the next. Those kinds of situations use a lot of purposive sampling. Snowball sampling, as you can think of, a snowball essentially starts smaller, rolling down a hill. It gets bigger, 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 and it hits other pieces of snow, causing lots of snow to be released in different ways down a mountain, causing an avalanche. The best way to visualize snowball sampling is you start with 1, 2, or 3, or 4. Doesn't matter how many. Doesn't have to be an increase by 2. But the idea basically is that, let's say you are trying to interview people from a difficult to access population. Examples of that would be, let's say you're trying to speak to individuals who have been criminally prosecuted and sent to prison and are now rebuilding their lives after having served their time. These records are not necessarily public, and it's hard to access these people. But if you were perchance to be able to contact one person, they might be able to give you contact information for other people that they know who are part of the same program. Obviously, you'd hope with consent. And that way you can start to build a sample from 1 or 2 people. Other difficult to access groups could be people who have faced some kind of a traumatic experience and meet only as in support groups, former alcoholics who may have met in support groups. Basically, groups who prefer that their identity not be made very public. And in those situations, a snowball sample is useful because one person can lead to the next and so on. Snowball sampling can also be used to track down experts in certain areas who you may not easily be able to identify using the internet or your regular inquiry methods. Systematic matching works well when population sizes are very different. So if you want to ask the question, how do East Indian students experience culture clash when they come to Laurentian as compared to other international students or even students coming from First Nation communities? The population size of East Indian students coming to Laurentian is significantly different as compared to, say, students coming in from First Nations communities. And in such a situation, if we wanted to do a genuine study, we'd have to do a little bit of a match wherein if we took, let's say, East Indian, First Nation, we had a certain number of male students, we'd try to match that up with the same number of male students, perhaps similar in some characteristics, maybe academic performance, maybe language skills, and so on. And there's an effort to match so that the comparison can truly seem legitimate or valid. So these are different types of non-random sampling. Read the section well, use the examples that they use in Chapter 9. I believe it's Chapter 9 or is it Chapter 8? Oh, well, sorry, my apologies, Chapter 8. And it provides different examples from what we are discussing in this lecture. So go ahead, read the examples, familiarize yourself with the idea of these different forms of sampling. And if you have any questions or concerns about how any of them works, please feel free to email your instructor. The opposite of non-random sampling is random sampling. And the idea of random is the fact that the instructor or the professor or the researcher controls very little of how that sample is drawn. The simplest random sampling is called essentially simple random sampling. And when you think about it, simple random sampling is done a couple of different ways. One is if you think about a dark bag with a bunch of different colored marbles, and they all feel the same, they all weigh about the same. And if you were to put your hand in and pull a marble out, you couldn't really predict which color you're going to pull because they all feel the same, they're about the same size, and you can't see what you're pulling out. It would be a random event. A coin toss is a random event unless you knew exactly that the coin was biased to one side. So a random sample basically involves drawing a sample in which the researcher has little to no control. Bingo is another method of it's a random sample situation where you pick up a number which you don't control as sampler. You can also get random numbers online. There are lots of random number generators, and most scientific calculators will have a feature where you can get random numbers. And the reason you do random numbers is if you have a population of 1,000 and you don't want to sample 1,000 people asking them about, let's say, their educational background or the years after high school that they've spent in university, you can get a smaller sample, a random sample of 100 or 50. And to know that you're truly pulling out a random sample, what you have to do is you have to have something that tells you which numbers to pick. So if you have 1,000 people, you label them 1 to 1,000, and your random number generator through your calculator, or at the end of your textbook, there's a random number chart as well. You can use different devices essentially to pull your random numbers up and get those representatives of those numbers as part of your sample. Systematic sampling is a little different. Let's say you have 1,000 people and you organize them by last name. So let's say you organize by last name. So you have all the A's, B's, C's, and so on, and then you get to the Z's. Okay. Now, in a systematic sampling method, what you can decide is I'm going to pick from the top, starting from the top. I'm going to pick every 10th name. So you go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and then you go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. The benefit of a systematic random sample is it is better than simple random sampling as it further eliminates any researcher bias. Because when you randomly sample, the researcher, without knowing, might have a certain bias towards, say, if you think about the bag of marbles, they may always go towards the left or always go towards the right. It might just be habitual. So you eliminate any of those kinds of biases as well when you go with a systematic random sampling. Now, stratified random sampling, think of it as a combination of quota, which is a kind of non-random sampling procedure, and then randomizing within it. So for example, we took the example of Francophone male and female students. So when you think about it, you have male students and you have female students. And while you have to pick 50, there's really nothing telling you that you cannot randomize the 50 that you pick. So essentially you're stratifying or strengthening to pick Francophone students, either male or female, but within that stratification, you're randomizing the sample. So that's called stratified random sampling. Cluster sampling is, let's take an example, and it's best illustrated using an example. What happens if I want to measure the frequency that my neighborhood Tim Hortons is a venue for socialization between 9 a.m. and 5 p.m. for older adults? Okay. Um, well, let me restate this. I think it should be stated a little differently. What happens if I want to measure the frequency that the average neighborhood Tim Hortons is used as a socialization venue for older adults between 9 and 5? So Tim Hortons is present predominantly in Canada. So if I think of Canada, uh, there are probably 3,000, 4,000 Tim Hortons. And if I want to think about how many Tim Hortons are actually used as a venue for socialization, which Tim Hortons do I pick? Which cities do I pick? Which locations in those cities do I pick? How do I do this? So I need to randomize all of these Tim Hortons. I also need to randomize uh, how much time is we spend monitoring one or two or three Tim Hortons or one or two or three areas. So it's easier to group them as clusters and study individual clusters rather than study all of the Tim Hortons and randomize them without any system. So we divide all of the Tim Hortons by geographical areas into small clusters, and we start to study each cluster. We randomize within the cluster, and we pick up perhaps one or two Tim Hortons in each area. Yep. Similarly, if you wanted to ask the question as to how many pets are in each household in Sudbury, we know there are at least 60, 50, 60,000, 70,000 households. Very complicated to study all of them, but it might be very much easier to divide Sudbury into clusters and start looking, randomize those clusters. Let's say this is the city of Greater Sudbury. I'm just making a random map which looks nothing like Sudbury. Let's divvy it up into clusters. And we can label these clusters. 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on. Let's say we have 100 clusters. We can randomize, and maybe we can pick up 5 or 6 clusters, and then we can study each of those clusters for household pet occupancy. Okay, so that pretty much summarizes the different types of sampling. Go ahead and read Chapter 8 and answer the questions at the back, as always. Now, sample size is important in quantitative research. As students, for most student projects, even though it's ideal to get large samples, students, undergraduate students, spend about perhaps 6 months on their research thesis and project. And off that, maybe they have about 2 months to collect data. So it doesn't make sense to have a very large sample, particularly if the question is well-defined, narrow, focused, and you can get the answer with a truly representative sample. So although size is a good predictor and you want more size, for student projects, about 30 is a good sample. So when you draw a sample as well, you have to analyze. So for example, this is an example of household income and as to whether people enrolled in a health and fitness program. And then we're looking at, how the sample would respond. A well-drawn sample would respond very much similar to the entire population itself. Okay, that's pretty much it for Lecture 8. Go ahead, finish all the exercises at the end of the chapter. If you have any questions, email your instructor and complete any assignments or discussions that you have in the module of the study guide. All right, thank you, and see you at Lecture 9.